Hello and welcome back to my YouTube channel. In this video, I'll be going through the solution to exercise 3.5 from the C programming language textbook by Kernighan and Ritchie. Now, exercise 3.5 says to write the function itob that converts the integer n into a base B character representation in the string s. In particular, itob formats n as a hexadecimal integer in s. Now, I've copied over the reverse and I2A function that's been given in the book. I know it's called I2B here, but the actual implementation is I2A that's been given in the book. And then here I have a main function that just tests the I2B program function. Now, if you have any experience with like working with binary numbers or even like base 3, base 4, base 16 hexadecimal, you'll know that to get the last digit, or like to get the digit in a representation of any base, what you have to do is take the modulus of that base, and then you have to reverse after everything. That's what this reverse is for. That's essentially what this function does. So here we take modulo 10, but what if we wanted like to convert into binary? What we would do is we take modulo 2, and here we would again do modulo 2. And this would give us the individual bits or the individual numbers in the binary representation. It would give us either a 1 or a 0. And that's pretty obvious because modulo 2 can only ever be 1 or 0. You can't have more than 1. It can never be 2. That's just maths. Similarly, if we wanted modulo 3, you do 3. Now we want, sorry, not modulo 3, base 3. Now we want base B, so I'm just going to do that. If it's a bit confusing, I recommend you like look over converting different bases into numbers. Okay. Now what we need to do then, like this is not enough. The reason being is, if we pass in 16 as our base, this might be 15, for example. This might evaluate to 15. But the question is, what character is 15 places after 0? The character 0. Well, I can tell you it's not going to be a number, because after the character 0, it only goes up to 1, 2, 3, 4, 5, 6, 7, 8, 9. After that, it's just some random stuff. So we need to make sure that it's going to be a number. Otherwise, we should make it a letter being A, B, C, D, E, or F. So let's use an if-else statement. And actually, before we do that, let's convert or find what that individual number or bit is going to be in our string. So to do that, I'm going to use an integer called digit, and I'm going to let it equal our number modulus the base. And I'm going to say if digit is less than or equal to 9. Well, what does that mean? That means it can be represented using a number. I'm just going to take this and replace this with digit. Else, what does that mean? That means the modulus must not be less than or equal to 9, so it must be greater than 9. So it's either 10, 11, 12, so on and so forth. Well, if that's true, I want to convert it to an A, B, C, D, E, or F. Now, I can't just do this because A itself is supposed to represent 10. So if I have, like, I don't know, if digit was 11, I don't want to go 11 past this. I only want to go 1 past it. So I got a minus 10. I got to compensate. All right, and that should be good. Now, if you wanted to be a bit more terse and not use this as if else, you could use the ternary operator. You could just do let's see, the condition is digit less than or equal to 9, and then if it is true, then I want si to be equal to digit plus 0. Otherwise, I want it to equal digit plus a minus 10. Now that's using the ternary operator. I'm not going to use it because I don't really like it. I think it's a bit unreadable. I'm going to stick with my if else, and that should be okay. So let's try and compile this. Okay, runs, compiles. Okay, let's see if it runs. The number 32414 in base 16 is 7E9E. Now I have this open here, and you can see 32414 is indeed 7E9E. Now, just to make sure, I think this is even cooler in my opinion. What if I let the base equal 2? I'm going to be converting straight into binary, which, I don't know, that's kind of cool in my opinion. Let's see what we get. We get that. So 0, 1, 2, 3, 4, 4 zeros after, 2 zeros after that. Let's see. 0, 4 zeros, 2 zeros. Yeah, it looks like the same thing. And then there's like a 0 and a bunch of ones. Let's just double check. A 0 and a bunch of ones. So that's kind of cool. So that's the itob function. That'll be all for this video. Thank you all for watching, and I'll see you all in the next one. Bye-bye.